Hello everyone, myself Dr. Vishwas. Today I am going to explain chapter 6 of this subject, digital circuit design using Parallel. In chapter 6, we'll study briefly about user defined primitives, UDP, that is UDP. A UDP is instantiated exactly the same way as a primitive gate, that is, the syntax for a UDP instantaneous is identical to that of gate instantaneous. Defining an UDP. A UDP is defined using a UDP declaration which is of the following syntax: primitive, UDP name, output name, list of the inputs, output declaration, list of the input declaration, register declaration, and initial statement. Then comes the table part, list of the table entries, and table and primitive. In here, with the code, our code will finally end. A UDP definition does not depend on a module definition and thus appears outside of a module definition. A UDP definition can also be in a separate text file. A UDP can have only one output and have one or more inputs. The first port must be the output port. In addition, the output can be at the value 0, 1 or X. If the value Z appears, in case Z is actually not allowed. If in case the value Z appears on the input, it is treated as an X. The behavior of an UDP is described in the form of table. The following two kinds of behavior can be described in an UDP: combinational and sequential, that is edge triggered and level sensitive. First comes the combinational UDP. In a combinational UDP, the table specifies the various input combinations and their corresponding output values. Any combination that is not specified is an X for the. Let us take an example of a 2:1 multiplexer. Here is given the primitive and the UDP name, that is max 2 × 1, and the output name Z, and the list of inputs HF, BAY, SEL outputs in the here we are describing the table part, and table and primitive. The question mark character represents a don't care value, that is it could be either 0, 1 or X. That is not our concern. The order of the input ports must match the order of the entries in the table. That is, the first column in the table corresponds to the first inputs in the module, is HF, second column is BOI, and the third column is cell. In the table for the multiplexer, there is no table entry for one input combination, 1X. Is the output default to an X? Let us see an example of a 4×1 multiplexer using a 2×1 multiplexer. The module is the unit name marks 4×1 Z, which is the in output, and these are the input values. The input ABCD, input 2:1 cell, it is a 3 cell 1 cell 2 vector, the 2 vector 1, and output set parameter t is equal to 2, t is equal to 3. Max 2+1, t is default, and TL, this is the TL where it is inputs of A, B, and SL1, TP where it is input of C, D, A. And finally, the final marks 2+1, where the output is Z, and the inputs are TL, TP, and SL2, the N module. Next, let us see what is sequential UDP. In a sequential UDP, the internal state is designed using a 1-bit register. The value of this register is the output of the sequential UDP. There are two different kinds of sequential UDP. One that models level sensitive behavior, and another that models edge sensitive behavior. Initialization of a state register. The state of a sequential UDP can be initialized by using an initial statement that has one procedural assignment statement. This is of the form initial register name 0, 1 or X. The initial statement appears in the UDP definition. The level sensitive sequential UDP. As long as the clock is 0, Data passes from the input to the output, else the value remains less. Here is an example of D type latch. Primitive latch. Q is the output, clock and here the input, output Q, register Q, input clock and here is the table for the D type latch table. Here is the table part, N table and primitive. The dash part also implies a no change. Note that the state of the UDP is stored in register Q. Edge triggered sequential UDP. A D-type edge-triggered flip-flop modeled as a edge-triggered sequential UDP. An initial statement is used to initialize the state of a flip-flop. Let us see the example of a D-type edge-triggered flip-flop. Primitive D edge flip-flop, Q output, and these two are the input. Here it is specified Q output and input. Initially, the Q is will be 0. Uh, Here is the table for the D-type edge-triggered flip-flop. Then N table and primitive. The table entry 01 indicates a transition from 0 to 1. The entry 0x indicates a transition from 0 to x. This entry indicates a transition from any value 0, 1 or x to 0, and this entry indicates any transition. For any specified transition, the output defaults to an x. Here is another examples of a 4-bit register of a for edge triggered sequential UDP. Now let us come to mixed edge triggered and level sensitive behavior. It is possible to mix level sensitive entries and edge triggered entries in one table. In such a case, the edge transitions are processed before the level sensitive ones are processed. That is, the level sensitive entries override the edge triggered. Here is an example of D type flip flop with asynchronous here. Primitive, here is the name primitive name D asynchronous flip flop. The output part and the rest of the input part here it is specified. The output is Q, register Q, and the input part. Here is the table for the D type flip flop and table and primitive. Here is another example of a 3-bit majority circuit of a mixing edge triggered and level sensitive behavior. As you can see, this is the example given. The summary of the table entries. For sake of completion, listed in the below are the possible values that could be used in a table entry. As you can see, this is called the treble entry. Write the symbol where it is given the symbol in the meaning. 0 indicates the logic 0, 1 indicates the logic 1, x indicates unknown. This question mark indicates any value of 0, 1 or x. B indicates any of 0 or 1. This dash indicates that there is no change in the value. AB indicates that value change from A to B. Thank you.